Alright, hi everybody. Today we're going to be working on the last section of Chapter 4, which is Section 4.7. We're going to be identifying and comparing numbers in the real number system. So we need to talk about what a real number is. Yes, there are things called imaginary numbers. You will be doing those in high school. And we're going to be solving equations by finding square roots. So we have a couple parts to go through. I think there's 4. The first one is classifying numbers. Irrational numbers. These are our new set of numbers you're going to learn about. They are numbers that are not repeating and they're not terminating. So they're going on forever and we can never put the bar over them. Some examples that are like that. This number right here. Bear with me, the board is going slow. Let's delete that out. Here we go. 0, 1, 0, 1, 0, 0, 1, and so on. We keep adding a 0, so there's never a point when you could put the line over it. So it's going on forever, it's never repeating. Square root of 2, if you type that in the calculator, it will go on forever, never repeat. The number pi, again, any of these are examples of irrational numbers. And when you go and look, we did this a while ago. Okay, the board is not smart. Oh, here we go. I gotta be patient. There we go. Okay, this is the whole real number system. Okay, the first numbers you learned about were the natural numbers. 1, 2, 3. No pieces, no negatives. Then came in the whole numbers, which have the naturals, but now you learned about the number 0. Okay, so here the natural, we have 1, 2, 2, 3, 2, okay. Whole numbers have 0. The integers have the negative numbers included. We had 0, 1, 2, and 3. We now have -1, -2, -3, all the negatives. Still no parts of numbers yet. Rational numbers are when we come into writing a number as a fraction. Okay, we include numbers like a half, -3/8. And now, all by itself, off on the side are the irrational numbers. Those are the numbers that go on forever and don't repeat, like pi. Okay, like the square root of 2. Okay, all these numbers are real numbers. Okay, they fall into the real number system. So basically you want to decide, do they fall over here or is it all by itself in the irrational numbers? So let's look at some examples. Slowly it will go down. Hopefully. Oh, there we go. Here we go. Classify the following numbers. 17. So you want to think, I would start with the smallest circle. Is it a natural number? Yes. So as long as you can tell me that it is a natural number, then it will be all of the other ones inside the other circle. N-A-T-U-R-A-L. Please bear with me. Whole number, integer, and it is a rational number. So it has 4 different types. -72 over 6, or the whole fraction -72 over 6. This, if you simplify this, because it's disguised right now, it actually equals -12. So now you need to think about the number -12. -12 is not a natural number because we don't have negatives there. It's not a whole number. It starts out with integer, so you write integer, and it is also a rational number. So this one only has 2. Square root of 225. It's the same thing as the number 25. This board doesn't like when I write numbers, so that means 25, right? 25 there. There we go. Which is a natural, a whole, an integer, and a rational. So it's the same answer as number 1, if you could copy that down there. And then this one, here we have repeating. So you need to think, can that be irrational? No, repeating means then that it is a rational number. It cannot be natural because we don't have pieces there. The only time we start having decimals is a rational number. So the only answer for this one is a rational number. Okay. Square root of 52. I will tell you, if it's a square root 1 and it's not a perfect square, we talked about perfect squares in the last lesson. If it's not 4, 9, 16, 25, those are the perfect squares, then this number will go on forever and it will never repeat. So all the square roots, as long as they're not perfect squares, these will all be irrational numbers. Click on a pen here. Irrational. Please write irrational like my board is doing in imaginary ink. There we go. Irrational. There we go. All right, part 2. Move this over. Part 2. We're going to be comparing some real numbers. If you have your calculator, now's a good time. I'm going to grab mine. All right, the square root of 125 is equivalent to 11.180, and it keeps going on forever. And we have 11 and 7/8, and 7/8 is equivalent to 8.75, so 11.875. So I'm converting each to a decimal and then comparing them. Well, 0.1 and 0.8, this makes this one greater, so you fill in the appropriate symbol. Okay, this one, same thing. I'll let you do this one on your own, number 2. Compare them, fill in the correct symbol. Part 3, ordering real numbers. Same as comparing, except you want to make all of them in a format that you can read, and then put them in least to greatest order. 6 1/4 is the same as 6.25. The square root of 38 is 6.16, and it keeps going on. So I'm going to just stop with that and see if I need to go further in a minute. 6.5, and the square root of 36 is equivalent to 6. So now we can compare them. The smallest one would be the square root of 36. Now, when you write them in order from least to greatest, you go back to the original numbers given, the original form. So square root of 36 would go first. Okay? 6.1 would be the next one, and that would be the square root of 38. Then 6 1/4 and 6.5. That's comparing. So that was part 3. Last part for today. Solving equations with square roots. Now copy over here some key ideas to remember. 1, your answer should include both the positive and negative numbers. Okay, when you're taking the square root, you should include both answers. Round to the nearest tenth when necessary. When you're solving this equation, when you solve an equation, I want to know what the variable equals. Well, this is w squared. To undo squared, we talked about you take the square root. So we're going to do the square root. If you do it to one side of the equal sign, you should do it to the other. Take the square root on both sides. You get w equals, and I'm going to write a plus or minus symbol here because we have to include both answers, because both of them will work in that equation. The square root of 169 is 13. And that's all you do to solve that problem. If it's just a single variable squared, you take the square root to both sides. Okay, number 2. R squared equals 50. To undo the squared, you take the square root to both sides. R will equal both the positive and negative. If you take the square root of 50, it's not going to give you, it's not a perfect square, so you're going to have to round. You're going to get 7 point, and there's a 0, 7. That 7 makes the 0 go up, so it's 7.1. And the last one, p squared equals 66. Take the square root. P equals both the positive and negative, and you get 8.1. That's it for today. Have a good night.